ahead and grade. You guys have had a chance to talk about the odds and ones you got stuck on that you could check and you could look at Calc Chat. I have the book open, I believe, and ready to go if we need it. But let's grade the evens first. Number 4, extraneous. Hey guys, that whole listen, shouldn't be talking thing. To be honest, I was challenged by my pastor on Sunday. He's like, praying, if you're always talking, when do you listen? Like, good point. Anyway. Number 4, extraneous. Number 14, hopefully it wasn't too bad, just combine like terms, and then it was just solve, which means infinitely many, so we have our 2 different places in our unit circle plus 2 pi n. Ew, they put 2n pi? Whatever, I like 2 pi n better. They like 2n pi. But here's the one thing to show you real quick. Couldn't you have done x equals like, let's see, you could have done negative pi over 6. You're not wrong. If you like smaller numbers, but you don't mind going negative, you could have gone that way. Or you could have had negative 5 pi over 6 plus 2 pi n. If you wanted to write it a different way, but otherwise there's not really much more of a way to write it unless you went all the way around and then kept going, but who did that? Don't do that. This one. Did you plus or minus square root? Did you realize every single quadrant was a possibility? But did you write it in a different way? It's very possible. So let me write out another way the answers could have appeared. The other answers could have appeared, let's see, square root of 3 over 3, 1 square root of 3. You could have had pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, all plus 2 pi n. The problem is, those are not your final answers. Can anyone explain why these are not the final answers? So what do I do if I need to get to x? Divide by 3. But when I divide by 3, he needs to be divided by 3 and him. He does and him. He does and him. Did anybody get annoyed? Or are you getting annoyed by me writing 4 different formulas? So what they did is they were like, okay, I guess you could have done it this way, and it would have been pi over 9, and 2 pi over 9, and 4 pi over 9, and 5 pi over 9. But you could have also combined the first and third quadrants by adding pi over n instead and dividing him by 3. Because the third quadrant is 180 or pi away from the first quadrant. You could have done the same thing with this guy. You could have added pi n instead of 2 pi n. Oops, I divided by 3. And that's pretty much what I assumed they did. They could have done pi over 9 plus pi over 3n. And they could have done 2 pi over 9 plus pi over 3n. Doesn't mean you had to. Just meant you could have. And for the lazy person, that was the more efficient way of doing it. Or at least the simpler way of writing it. Okay, number 28. Hopefully you changed sine squared to be 1 minus cosine squared. You distributed the 2. Sine squared to be 1 minus cosine squared. And distributed the 2 and then said, quadratic, and got it all to one side. Then realized the 2's go away, so all I have to do is pull out a GCF. Everything I've said besides the Pythagorean property has been good old-fashioned math. Okay, quadratic on one side with a 0, pull out a GCF, set each one equal to 0, and then its unit circle to the end. And they just wanted 0 to 2 pi, so I just went looking for when is cosine 0 or when is cosine negative 1. I don't want to sound like a broken record, aka something that just keeps on saying the same thing over and over and over. Maybe you guys don't know what records are anymore. Anyway. But if your brain is unable to go backwards with trig, you need to figure out a way to learn the unit circle better. And the cheater chart, I am almost positive, would be the easiest way for you if you don't have a way yet. However, I'm saying you need to figure out, because I'm here and I'm available and I would love to help, but I can't say we and I can't say I unless you come see. It's your choice. So hence, you need to figure out a way. and I'm saying I'm available, all you do is come in, we get a whiteboard. If you don't know the unit circle, you can't finish any of these problems on your own. And that's dangerous. Because if you don't remember, 5-4 and 5-5 say, here are more formulas. Guess what? You're still solving. You're still solving. Okay, sometimes it's a T-proof, and sometimes it's like a common denominator, and sometimes it's making a triangle. But you're going to have solving as a direction, which means get it down to trig. The words on the board. Trig. One place, one side, numbers on the other side, unit circle backwards. And if you can't do unit circle backwards, you need to figure out a way. I am a way. Come use me if. I don't know. And if you don't want to use me, then you need to figure out another way. Use an older brother, an older sister, use an online tutor, use a nifty like 5-finger trick that Maggie Corey is teaching all of her friends at Berkeley, and they love it. Yeah, I know, ironic. Well, because 0, well, the easier one is pi over 4 is the middle guy, right? Root 2 over 2, root 2 over 2. Pi over 3 is the higher guy, right? Root 3 over 2, 1/2. Pi over 6 is the lower guy, 1/2, root 3 over 2. She just has it memorized, and it's like the first quadrant of the unit circle. All in her life. It's pretty cool. Anyway, there are lots of ways to study, to learn, to know. You have to have a way to be able to go backwards. Anyway, so she could say, when is cosine 1/2? Sadie, I'm so sorry. Give me 1 second. When is cosine 1/2? Cosine is the x. Is 1/2. Did I just do it backwards? Cosine the x. Sorry, he's this guy. Cosine is 1/2 at 1/2. There we go. At pi over 3. But first quadrant, it's not negative, so we have to figure out what quadrant is going to be a negative. Anyways, I'm scrolling down. You guys can check. Sadie, what's your question?
I got the wrong number.
Oh, yeah. Go grab the right one. And then I can scroll back quick if you need to grade. Okay. Sorry about that. Same thing with T-proofs, but T-proofs are a little bit harder. I get that. They take creativity. But there are a lot of just doing legal math. And if you can come in and do one with me, or let me sit down, put this on a whiteboard. Put this on a whiteboard and see what you do. A couple girls did that a couple days ago. Hopefully it helped. So I was like, ooh, illegal. Ooh, think this way. Maybe it didn't help, but I hope it did. Solve, solve, solve. You could have gone to secant, but ew, gross. Who knows secant? Just do cosine and like flip it all around. And that's a lot easier. Pi over 3 and 5 pi over 3. And just a heads up, guys, on like test answers, multiple choice, making it match, just for you to have an idea, I'm probably not gonna have like multiple choice answers of like, oh, you did this one, but not both. I'm gonna count you off. It's probably more of a find one of them that works. That's probably what it's gonna be. Maybe not like listing them all out, but just find like A, B, C, or D. Which one is one of the right answers? Just in case you're thinking ahead to what or how I might test these. Number 40. We had to use that multiple angle thing that Emma asked on yesterday that we touched on 2 days ago that Nathan and Nikki were both like struggling on the smartboard with. Do the sine inverse first and then divide the 2. And that's why you ended up with pi ends. You guys had to see that in your odds when you were checking. Sometimes they did 2 pi ends, sometimes pi ends. Sometimes it was just to be lazy and write the answers in a shorter fashion, but sometimes it was necessary when you had to divide by 2 or 3 at the end. Ooh, here's that nasty quadratic formula one. And this was one where, I mean, they changed the notation, but basically they're like, that's not square root of 3 over 3, 1 square root of 3. So they did their calculator. And they knew how tangent worked. And so they actually started adding pies to it. But if you guys wanted to be super snazzy, couldn't you have graphed this and been like, hey, tangent, hey, tangent, hey, tangent, when are you negative 2? And couldn't you have just found intersections and been like, cheated the system, didn't even think about tan inverse? You're using your calculator anyway. That's a snazzy way to use it. You could have graphed your tan, and you could have graphed your negative 2, and you could have just found intersections. And you would have known when to stop by limiting your x min in your window and your X max to only include what you were allowed to be using. So that's snazzy. We would have had to do the exact same thing with this guy. You would have had to graph your tan, graph your y equals 2/3, and you would have had to find those intersections also. Might have been easier than the whole plus pi.
A little worried by no one writing anything at this point because number 60 was nasty with the quadratic formula, was nasty with setting equal to, was nasty with plugging into your calculator, and was nasty for finding all of the answers. My little teacher brain is either ding, 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 they don't care. Ding, 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 they're all geniuses, but I know their test averages. Ding, 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 they're all just using Slater and not really paying attention. But I can't really, once again, I can't force you to do anything. It's your choice. Nathaniel. Yes. P.S. They are in radian mode for sure, because of 0 to 2 pi, degree mode would not have cut it. Degree mode would not have cut it. Number 86. Literally, Nikki was like, what? You gotta be kidding. They're just saying, hey, 3. The answer's 3. Why? Because it hit 3 times. That's it? That's it. They intercept 3. So it's a 3. 2?
Oh, it's 3.
I thought you said 3. I remember you saying 3 the other day. Yeah, I think it hits 3 times. And then number 94, is this the Ferris wheel one? Okay, this one's kind of nasty. Kind of practical. Because the Ferris wheel moves in a sinusoidal wave. We talked about that way back when in chapter 4. You would have had to have set its sinusoid equal to 53, because that's when it's at its middle. 53 is the sinusoidal axis, and then it goes up 50, down 50 from there, because it can't go down 53, or your portable feet are like hitting the ground every time you come around. So it's a little bit off the ground. So we have our amplitude of up 50, down 50, and it's in the middle is 53. And so when they say the middle, they said equal to 53, which means, hey, those cancel and I get 0. So you're just solving for a 0. Divide, sine inverse both sides. Sine is 0 at 0 and pi, and then you can actually do a lot of this by hand as far as adding fractions, which is why they have really nice numbers. So if you're at the middle at 8, and if you're at the middle at 24, isn't there 16 between them? 16 is a half circle, 32 is a whole circle. So you can figure out how long they're on the ride. You can figure out if they're halfway, and then the other half, they've gone halfway in between there. 16 seconds, they were at the top of the ride, and then 32 seconds, they'll be back. 32 seconds, they'll be back. 32 seconds, they'll be back. And that's what's going on in all of this math down here. Although I wouldn't have even done any of that work. I would have just used my logic to be like, oh, he's here, and then all of a sudden he's over there, halfway in between. He had to have been at the top. Then I would have figured out the halfway point and then doubled it, and then like, sweet, I can figure this out without doing any of this crazy period, amplitude stuff. So it's like add 32, add 32, add 32, add 32. That's how many times you get to go around the Ferris wheel. Guys, it's on the video if you want it for longer. Seems like you're able to find solutions somewhere, so if you want to, you can go check out the YouTube video. But we're going back to the beginning. Here's the list of homework problems. Are there any odds that your group wasn't able to help out with? Or any evens that right now you're like, please slow down just a little bit. Can you talk it through a little more? Kayla?
23.
23, that's an odd. Nice. Anything else?
27.
Mm-hmm.
67.
Nice. Guys, I'm loving you asking the odds. Not that you couldn't ask the evens, because you're actually caring about where the solutions come from. 23, 27, and then, so I just make sure I remember that you're going to 67. Number 23, solve. We're trying to do 2 pi n stuff, right? Kayla, the name of the game of this one is, do you know the math? And name it circle. Because the math says, whenever I have, now in algebra, some people get confused by this also. It doesn't look as nice or as neat as something like this, even though it's actually easier. If I was solving algebraically this guy, equal to 0, right? This guy, same thing, even though he looks different, because he's his own factor. So because of that, check it. Equal to 0. And now when you have that, you just gotta think, can I do unit circle backwards? Well, this guy you have to figure out we're talking about -1. Now, for your brain, cheater chart backwards, or like the order pairs. So cheater chart backwards. So Katoa, we have 1, 2, 3, 0, 1. Right? 0 is at 0, 1 is at pi over 2. So if I'm thinking, alright, I know sine is 0 here, and thus if it's here, it's also over here. And then I know sine is 1 here, and so that means, okay, so 0 and pi, x equals 0 plus 2 pi n, and pi plus 2 pi n. Those would be my 2 unit circle values. Or the book is going to say, you know what, it's just every pi, like 1 pi, 2 pi, 3 pi. So they're going to take all of this and just shorten it to be like with every pi. That's how they're getting it all. But then for sine to be -1, now here's the problem. I can't use pi over 2 because that's positive. But I will be using 3 pi over 2 and all of this goes. So whichever version, that one and that one, or their shortened version of, I got them all in that. Is that cool? Spencer, 27? Okay. 27 switches directions to looking only between 0. Oh yeah, that one's fun. This was one that Emma was curious about yesterday. I think this was you, Emma, right?
Yes.
Depending on how outside the box you think, or just how naturally math comes to you, a lot of people would be like, divide both sides by tangent, because then I get rid of 1. You're not mathematically wrong in that you're going to get correct solutions. I'm just assuming. You maybe didn't do that. You're not going to be wrong if you go this route. You're just going to miss out on some of the solutions and only find some of them because you just ignored that tangent, basically. So the other way, to not skip over some solutions, maybe that's the best way of saying it, to not ignore anybody, would be to get everything to one side by subtraction to get that equals 0. That Vanessa was saying the other day, like, don't we need the 0? We do if we're factoring. And the nice thing is there is no constant. If there was a constant, like, throw the pencil or walk out the door, I mean, it'd be hard because you have a cubic. But since there's just 2 variable terms, pull out your GCF and all of a sudden life gets better. Now, Kayla, it's similar to yours in that we're going to go ahead and take him equal to 0, take him equal to 0, right? So I'm looking for when tangent is 0, and I'm looking for when the square root of tangent squared is the square root of 1/3. If I add the 1, divide the 3, plus or minus square root both sides. Plus or minus square root because absolute value can be positive or negative. So that's why I'm going to go here. But I don't want to think about that because I'm like, that's not in the unit circle. Unless I realize that's just 1/√3, square root top, square root bottom. Distributive property of exponents. I technically can distribute exponents across multiplication and division. This is a guy I should know. So I have square root of 3/3, plus or minus every single quadrant. I have 0. Maybe no one's brain is like mine, but maybe some of you, your brains are kind of like, I'd rather get to know this guy and then be able to answer quicker. Getting to know tangent is knowing his graph. And if you know his graph, maybe you know that his zeros, without even having to think about like the cheater chart, are just at 0 and at pi and at 2. No, sorry. That's pi over 2. Yeah. 0 pi, 2 pi, 3 pi, 4 pi. So without the cheater chart from the graph, I know that this is going to be every pi n, the shortened form of like what I just showed with Kayla's, the shortened form. Cheater chart though, we could have also thought SOHCAHTOA, square root of 3 over 3, 1 square root of 3, 0, undefined. We could have also figured out it's at 0, which will repeat if you're thinking unit circle, 0, pi, 2 pi, 3 pi, 4 pi. Also pi. Speaking of cheater chart, we could have also gone backwards to our pi over 6 guy. And this will be every pi over 6. And so, Spencer, here's that. They're going to write it in a way shorter form. Because we could do pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, because of the plus or minus. They could group that together and do plus pi n. They could group those two together and do plus pi n. Or they could be super snazzy and say, hey, up pi over 6, down pi over 6. They could even write it in a shorter form. I don't know which form they wrote it in, but you're getting your solutions either way. Is that cool? Yeah, good job. That tangent cubed, he just looks like a beast, but he's not that bad as long as you remember a lot of math stuff that goes along with plus or minusing, how to simplify square roots, how to factor. And then, wait, sorry, 67? Okay. 67 is using your calculator. I'm going to grab out my calculator because I can already tell that this is going to be one where it's not unit circle backwards. Correct me if I'm wrong, but I'm pretty sure from the directions. Nice thing is he looks a lot like other stuff we've done in that the sine squared is going to become, yeah, good, Pythagorean, right? You guys shouldn't need me to distribute 2's and get all the stuff on one side. And to be honest, I'd move it all over there because I want a positive. Positive what? A positive 2 cosine squared. I have 4 minus 2, which would be 2. I'm subtracting. Okay, that's just a good old-fashioned rearrangement, and I actually move it that way to make the negative not be in front. I would love for there to be a way that this could work. Remember, A times C. The problem is, sure, 4 and 1, but a positive times a positive. Wait. Oh, I moved everything that way. So I have 2 minus 2 cosine squared, and I'm like, I don't like you ever being negative, so I added him, subtracted him, and subtracted him. Or I could have subtracted the 4 and multiplied everything by a negative 1. I just didn't want a negative 1. Wait a minute, this does work, right? Asterisk people, what do we put on top? Someone asked me this the other day. Got it. Simplify. We can go ahead and say 1 cosine x plus minus 2. 2 cosine x minus 1. So then I have cosine, ooh, tricky, and cosine x equals 1/2. Why am I saying tricky? I'm about to say forget him. How high does cosine only go? 1 to negative 1. He can't go beyond. So forget it. You could try doing cosine. They're saying use cosine inverse. Oh, that's ironic. Am I doing this right? I don't think you need to use your calculator. I mean, you could have because it didn't look like unit circle and gotten an error, but you could have also just known. And then this one is unit circle. Is that what you want? I think it's making sense. I think it was in the section where you might need to use your calculator just because this 2 is not unit circle. And so maybe you would have needed to go to your calculator to realize none. But now we have just good old-fashioned unit circle. I think it was 0 to 2 pi. If anyone wants to double-check me, I'm pretty sure it was in the interval 0 to 2 pi, at which place I would think, so 3, 2, 1, 1/2 is at pi over 3. Positive, cosine is positive in all, and the students take calculus, so I need pi over 3. I can't do negative pi over 3 because I'm only allowed to go positive
positively. So that'd be 5 pi over 3. Good question, guys. I know I make it look easy, but this should be like the polishing off, making a correction, not facing it for the first time. Oh, sorry. The day before the actual test. The actual test is on your calendar. Sorry.
Keeping track of 6 classes with 5 different calendars just throws me off sometimes. Has anyone looked at the calendar? We have to do 5-4 today, 5-5 Tuesday and Wednesday. It might be next Friday. Remember, you guys have a link to this in Google Classroom. Just go to, not the original tab that always comes up whenever you open Google Classroom, but the next one, Class Resources. Your calendar's right there. There you go. Next Friday is the problem part. So next Thursday is the formula part. Because 5-4 is due on Tuesday, 5-5. Take a couple days on. But remember, half those formulas we don't have to memorize. We're just practicing problems on. And then formulas. Test review is due. Oh, I didn't put the due date. It's due on Friday. Because it's like, it's more the problems than anything. So I'm making it due the problem day, not the formula day. Yeah. So test review is due here. But I'll make sure to have it up. Unless you guys, do you want me to put up the test review early? I can. Is anyone going to be working on the test review this weekend? Let's be honest. Okay, so I'll just wait to put that up until next week. All right, guys. If you guys don't mind, we're going to go play with section 5.4. I'm going to give you some hints for memorizing these formulas. But for some reason, I don't know. 60 seconds. I don't know. Maybe a minute. Same thing. Maybe 2. We get to take a break, and you guys have memorized stuff before, but I don't know how. How have you memorized? Have you memorized by writing it over and over and over and over, like a missed vocab word? Or have you been forced to write it? Have you memorized by saying it out loud over and over and over? I have my calculus kids with their formulas. I have them actually quoting out loud, but they have an option of handwriting, but it takes longer, so it kind of counts as triple. Do you just do Quizlets, and you're just like, hopefully it works? The morning of. Morning of is never the best time to start studying, but I'll be honest, I was always a crammer, and for my brain it usually worked. But then the day later, 2 days later, I'm like, huh? I knew it back then. How does your brain work? Does it find patterns? Does it like to put something to music, Mr. Strike? Does it? Have you guys had it yet? You haven't? No. Some of you haven't. But at least you've heard other songs, I'm sure. Do you put stuff to music? Does that help? Do you put rhythms? Are rhythms better than even like musical notes? Do you find some way to make pictures? Some brains can be geniuses. This one girl I knew in high school, she had to color code everything. If she color coded it, she was awesome. Like memorizing whole books of the Bible word for word. Backwards, forwards, could jump to any verse you want. Whatever you need, color coding, writing it out, saying it out loud, etc., etc., etc. We got it. Don't worry, it's cool stuff. I got you. Napkins. Put it down, please. Okay. Have you not found a way to study yet? Okay. Can I just give you a few of my tricks for these specific? Ready? Sine. Sine stay the same. Cosine. Signs change. And co means with or together. I'm using my grammar prefix knowledge, and I'm using C with C and S with S. Sine same, cosines change. And that's all I need to basically have all of them. What? Yeah, because check it. How can you think sine's the same? Well, easy. If it's a U plus, there's going to be a plus. If it's a U minus, it's going to be a minus. Cosines change. Sorry, sines change. Plus becomes a minus, minus becomes a plus. Ready? How does that work for tangent?
Who is tangent in terms of sines and cosines? Sine over cosine. Ready? Same over change. Ha! Got it. Same over change. Got it. Okay, that's just the sines. What's the co with or together, and how does that help with everything else? Co. What's true with cosines and sines? They're together. Oh. Co. Cosine, sine. Cosine, sine. Well, if co's with or together, then what's sine? Sine, he's not together. Oh, cosine. Cosine, sine. Sine, cosine, cosine, sine. They're not together. So they start off, and then with or together, yay, they're grouped. Oh, not grouped. How does that help down here? Sine over cosine. Together, not together. Together, not together. Okay, I know it's silly, but for my brain, that's enough. For your brain, maybe. Or maybe you need to start color coding, putting pictures, putting little like boxes and triangles. We do that in calculus too, with like boxes and triangles to try to make things make more sense. And I'd say at least 1/3 to 1/2 of the kids like the boxes and triangles way more than the f of x's and g of x's. It just makes sense. For you guys, I'm not going to go through all the trig properties and put shapes unless you come in and ask. And then I probably will because I'm not going to teach you. But figure out a way that works for you to study these, okay? The long story short today, when I come to something and I say something like, uh-oh, this is a sine of u minus b, do I have this formula memorized? Yes. Do I have all the formulas in chapter 5 memorized? No. You guys don't have to memorize the last box? I don't have the last box memorized. And there are these ones called half angles that I'm always like a little bit shaky on and the power reducing a little bit. But there again, I'm just trying to be able to be up here and teach you and figure out where you're struggling and try to answer and try to somehow motivate you. And the last thing you want to do is math and keep you awake. Oh my goodness. I'm focused on a lot more than just having your formulas memorized. I have most of them memorized though. When I'm up here and I start spouting out a formula, I'm going to warn you. I'm going to say, I'm plugging into a formula. But do you have to have it memorized when you're doing problems? No. Just be looking back and be like, oh, I see it. I'll have it memorized by next Thursday. I see it. I just get to use it right now. So, this one. Sines stay the same, not with or together. I need sine u cosine v minus cosine u sine v. I need to plug in sine of the first dude, cosine of the second dude, not with a negative, that's here, minus cosine of the first dude, sine of the second dude, not with a negative, that's here. And then I say, I think I got a lot of unit circle to go play with. You've heard me do enough unit circle over the last however long. You don't need me to explain how I'm doing this. Cheater charts, all students take calculus. I'm just going to fill in. Because sine of 7 pi over 6 is the exact same thing, equal to negative 1 pi. Might take you a little bit of time or a lot of time to get there, but can you get there? Cosine of pi over 3 is equal to 1 pi. Cosine of 7 pi over 6 is equal to negative root 3 over 2. Sine of pi over 3 is equal to root 3 over 2. One thing, if I were you, in a colored pen that like points you to what to study for a test, I would write a note to yourselves right now that the biggest mistake kids make on the test on this type of problem, that's right there, is they accidentally write the sine and cosine a second time, but it should be gone and just the fractions remain. If you're one of those, right now is a smart idea in the colored pen. This will be on the test. I can almost guarantee it. The most common mistake is to rewrite the sines and cosines when you shouldn't. They're gone. They're fractions in. I end up with negative 1/4 minus, just kidding, plus 3 over 4, because that's root 9. I end up with 1/2. Huh, that's funny. Kind of looks like a unit circle thing. This guy does not look like sine of u minus v. It's just a sine minus a sine. Okay, that sine sign is negative 1/2. This sign is positive root 3 over 2. I end up with negative 1 minus root 3 all over 2 with a common denominator. This page might look real weird, like, so they're just having me plug into the unit circle. Except there's actually something really, really important they're trying to tell you. Sign, sin, does not distribute. Look at the two. These are not the same, right? These are not the same. Sine of u minus v is not sine of u minus sine of v. It is not as easy as like, whatever, I'll pretend it's multiply and just pretend I'm getting the right answer. I'm getting the wrong answer. Sin, cos, tan, sec, and cot. They're not times. It's not sin times, it's sine of. So when you see something like a sine of u minus v, you cannot just say, yay, there's a formula to memorize. Okay? And the reason being is this is actually sine of, anybody realize we could have gotten common denominators? 7 pi minus 2 pi is 5 pi over 6. And what's sine of 5 pi over 6? 1/2, of course. It works with this one, not with that one. Anyway, all of that is just like, hey, the formula, it's a thing. And the reason it's a thing is because it's the only legal way to do that. Simplify that expression. You're going to be given, let me just put a couple examples up here on the board. You're going to be given a couple different types of examples. One of them might have you going forwards in the formulas with the unit circle. Other ones might have you coming backwards with the unit circle. Now this one says sine and cosine and tangent. Okay, we're just going to do, I don't know, we did sine a second ago. Let's do cosine. If they want us to find cosine of this guy, 11 pi over 12, they can tell us until they're blue in the face, like, go to the unit circle. And I'm going to be like, it's an over 12. I'm not going to the unit circle. It's not there. Unless either I figure out or, thank goodness, they tell me, okay, 12ths are not, but 4ths and 6ths are. And I can break them down to be that. And partial fractions, but let's not worry about that right now. And I can use my with or together. Signs change. With or together, now it's signs turn. I can use my formula. I'm using my formula, it's not magic. I can use my formula, and now all of a sudden, well, this is unit circle, and my answer will be exact, and I'll know the 12th. But this one over here, if you look at your formulas, this is the other side of the formula. This is the long, drawn-out side. And maybe, if you're like me, you're like, well, if that's the long, drawn-out side, can't I at least see if I can do this on my own? Sine, same, it's a minus. If it's not like an over 12, I didn't need to do all the work of plugging it in the long way if there's a short way. So sometimes the formulas are nice because it lets us avoid tons of work and say, I can do him. Square root of 3 over 3, 1 square root of 3 in the second quadrant, so therefore it's going to be all students' tangent is a negative. So sometimes you got to do it the long way because you don't know the shortened one. It's a 12. But sometimes you can do it the shortened way because you do know it. So the cool thing about the formulas is they can go forwards or backwards. Now guys, there are a few other things in homework like, oh my goodness, they can bring in a t-proof? Sure. Because he has formulas that go with him, and he has formulas that go with him. Or they could do things like make us make a triangle and say we know opposite and hypotenuse you could find. That would be you. Or we know, negative, he must be over here. Adjacent and hypotenuse, we could figure out him. And then we can use the formula and use the triangles to pull out the cosines and the sines. But basically, guys, you're simplifying evaluating, verifying, or solving with new formulas. Try it the best you can. I'm pondering mine for a second. I think I'm going to post the notes with the rest of the examples worked out, just in case you need something to look at that looks similar to homework problems. Does that sound good? All right, I'm going to work out the rest of the examples. I'm going to post them online just for homework help. So you guys are using the new formulas to do the old school 5-1, 5-2, 5-3 tricks, but I want to give you as much as possible to help. So all the examples will get worked out. You guys can look at notes online as you do homework. Bye, guys. Nikki, I see you in the